Hello and welcome to our next lesson. Today we are covering gravity, tides and orbits. Our learning intention today is students will be able to understand how gravity and the orbit of the moon causes the Earth's tides. Okay, our learning task for today will be to discover what is gravity, what does orbit mean, and how do tides work. Okay, so that's what you're going to be covering today. First thing I want you to do is the do now activity. So pick up two things. The things I suggest is maybe a pencil and a book. Okay, you can even use a textbook and drop them from the same height at the same time. Before you do that, I want you to think which one's going to hit the ground first. So one's obviously bigger and heavier. Which one do you think will hit the ground first? Don't do it once, do it a few times. And I want you to then, in your book or on your sheet, write down what happened and is that what you expected? Okay, so press pause and go away and do that now. All right, moving on, we are going to start with the big one. So gravity. Not only is it a blockbuster movie, it is probably one of the most important forces on Earth, or actually in existence. All right, so gravity, as we define it, is a non-contact force of attraction that pulls together all matter. Anything that you can physically touch has matter. Now, that includes things like the wind or air. Although it might not seem like you can touch it, you can. Okay, if someone gets a book or a piece of paper and fans it, you can feel that air. So it is something you can physically touch or feel. Okay, the more matter something has, the greater the force of its gravity. Okay, so the key thing here is it is a non-contact force as opposed to contact forces, which there's three types of. You have push, pull, and twist. Okay, gravity is a non-contact force, so it doesn't physically need to touch something to move it. Okay, when I move my computer mouse, I push and pull. Okay, they're forces. A non-contact one, you don't need to be touching it. Another example of a non-contact force is a magnet. Magnetic metals are attracted to a magnet. It doesn't physically need to touch it to move a metal. That's another non-contact force. Okay, so the pencil here again, you need to have copied this down. And this picture here is obviously people jumping out of a plane, skydiving. So what is it that causes them to fall towards the Earth? It is gravity. Okay, gravity pulls things towards the center of the body of that object. So in this case, the Earth. So no matter where you jump from around the Earth, you're always going to be pulled to the center of the Earth. You know, just keep floating around in the sky. What I want you to do in your first activity is watch this clip here. So it's defining gravity. It's a crash course for kids. Okay, this YouTube link will be in not the comments, in the description for the video. So don't type it out, just copy and paste it from there. So if you want to kind of minimize the screen, copy and paste that link across to another tab. Before you do that, just think of these two questions when you go into the video. So what does the weight of an object, or how does the weight of an object affect how fast it falls? Okay, and why do bigger objects have a greater gravitational pull? So they're the two questions that I want you to answer, either typed up or written into your book. And I want you to answer them in full sentences. So you would say, the weight of an object does or does not affect how far something falls. Okay, bigger objects have a greater gravitational pull because. Okay, full sentences, thank you. You can press pause, watch that, and then come back to this clip. Okay, next up we are talking about orbits. So an orbit is the path that an object takes in space when it goes around a star, a planet, or a moon. So here we've got an object moving around in a regular path around this, what looks like to be the moon. Okay, this here orbit is just a brand logo, but you can actually see around the outside there with my cursor, it's illustrating that an orbit is something you're circling around the word orbit. Okay, and over here we've got a picture of the Earth, or an image of the Earth with all the satellites orbiting, rotating around the Earth. Now, on some of them you can see they're actually oval shaped, so it doesn't have to be a nice even circle. Okay, it's just the path an object takes when it goes around a star, planet, or a moon. So it can be elliptical, which is an oval shape, or it can be spherical. So copy that down, and then we're going to move on to our next activity, which is all about orbits. So, as you know, planets orbit around the sun. We spoke about this last lesson that I took. That is the heliocentric model of the universe with the sun at the center, which is just here. And all these planets orbit around the sun. Now, this image here has them orbiting in nice circle shapes. That's not, in fact, correct. Okay, some of them, as I said before, orbit in elliptical shapes, which are oval shapes, and this also has them all on the same plane, orbiting around. Okay, they orbit in 3 dimensions, so it's a little bit more difficult than that. But what I want you to do for this activity is use the internet to research how long each planet takes to orbit the sun. So how long does it take for each planet to do one full revolution around the sun? In Earth, we call that a year. Okay, so days to orbit the sun. And you should already know, but Earth takes 365 days. A little bit more, but we average to say 365 days. So what I want you to do is copy this table and just fill out the days it takes to orbit the sun. Okay, what I've got here is my very educated mother just served us noodles. What that means is my stands for Mercury, V stands for Venus. Okay, educated Earth. If you can remember, my very educated mother just served us noodles, you can figure out, or you should know, the order of the planets as they go away from the sun. Okay, so press pause here. You can use the internet there to research the days to orbit the sun, and you might be surprised by how some of them go very quickly, but others manage to go very slowly. Okay, next up we've got tides. So tides are the rise and fall of the levels of the ocean. You've all probably seen high and low tides of the ocean. Okay, but they are caused by the gravitational pull of the sun and moon, as well as the rotation of the Earth. So tides cycle as the moon rotates around the Earth and as the position of the sun changes. So copying that down here, and I want you to get a diagram too. So you can either copy this into your book or just copy and paste one similar to this off the internet. But what it's saying here is this moon actually pulls the water of the oceans towards it. So the moon has a gravitational pull on Earth and also on the oceans. But because the oceans are a liquid, they can pull them a little bit easier. So it causes not as big a bulge as this one here, but a slight bulge on the side of where the moon is here, but also on the other side here, because it pulls the Earth a little bit towards the center. So you end up with a bulge on this side and this side, which results on these sides of the Earth, this one here and this one here, having high tides, while this one here and on the other side of the Earth result in low tides. Okay, now as the Earth spins on its own axis, you actually experience several high tides and several low tides every day. Next activity. So again, you're going to be watching this YouTube clip. Okay, it's a space science tutorial on spring and Neap tides, okay, which are naturally occurring phenomena. Okay, and the 2 questions that I want you to be thinking about and answering in full sentences are how many high and low tides are there in one day, and explain how the sun causes the spring and Neap tides. So they're your 2 questions. So watch that clip. Again, that's going to be in the details of the video, so you can exit full screen now, click on that one and open it up, and then answer these 2 questions. And then once you're done, come back to this clip. Okay, we're almost done, guys. Your next activity is a Kahoot here. So this is something pretty fun. It will be open up until Friday this week, so make sure you get it done before then. It's a list of questions about gravity, the tides, and orbits. Okay, so again, click on the link in the description for the video. Don't type all that out, it'll take you ages. And it's just 17 questions, and it's against all of year 7. Okay, so you're competing against 7A, B, C, and D. All right, go ahead and do that, and then come back to this when you're done. All right, that's almost it, guys. So we're just going to do our reflection. So our learning intention was that you'd be able to understand how gravity and the orbit of the moon causes the Earth's tides. Okay, what did you learn about gravity, tides, and orbits today? So our learning tasks were: what is gravity, what does orbit mean, and how do tides work? Okay, so what you've learned about them, you can put in here, and what can you improve on for next time? Okay, just a little bit of a self-reflection there. And then our last slide is what you need to submit. So make sure you submit your document with the week's work under assignments in your class on Microsoft Teams by the 15th of the 5th. That's next Friday, or this Friday, sorry. All parts with a pencil need to be copied down or typed into your document, and the activities that you need to have completed are: do now activity, the YouTube questions for activity 1 and 3. You need to complete your table, do the Kahoot, and then your reflection. All right. Thanks very much, guys. I'll touch base and we'll probably see you again in a week. Look after yourself.